Hello, welcome to Pre-Cal Lecture 4.6a, where we're going to discuss the properties of logarithms. So you are on your 4.4 to 4.6 note package, and we are up at the top of page 6. All right, I summarized them all on the board here, and they are on the first half of page 6 up at the top. All of the properties of logs that you have to memorize. So log base b of a product, so multiplication, you can split that up into log base b of x plus log base b of y. So the sum of two logs is the same as the product of what's inside of what you're taking the log of. If you have a fraction inside the parentheses, it's the same as a difference. So you can expand that into log base b of x, the numerator, minus log base b of y, the denominator. And then if you have the log base b of x to a power, you can bring that power out front as a coefficient. So that would be y times log base b of x. And then log base b of b, so that's a b, not a 6, log base b of b is equal to 1. So that's b to the first power is equal to b. And log base b of 1 is equal to 0. b to the 0 power would be equal to 1. So all of those need to be memorized. Now, before we start working a bunch of example problems, some common mistakes, make sure you look over these. Log of x plus y does not equal the log of x plus the log of y. And the log of x over, if you take the log of a fraction involving logs, that's not the same. That's not log x minus log y. So just make sure you're not fooled by an expression that looks like that, where you can use the properties of logs. Okay, so let's start going through the example problems. So our first example is to expand log base 8 of the cube root of x divided by y squared. Well, first of all, this is a fraction. So it's a quotient, and we would use this second law, property of logarithms, where we subtract the top. So this is the same as log base 8 of the cube root of x minus log base 8 of y squared. So this is the same thing as this. Now I want to rewrite this, the cube root of x. This is log base 8 of x to the 1/3 minus log base 8 of y squared. And so now we can use this property, this third property we have here. When you raise what you're taking the log of to a power, you can bring that power out front as a coefficient. So that's going to be 1/3 log base 8 of x minus 2, bring that 2 out front, bring the 1/3 out front, log base 8 of y. And that's all we can do. Really can't do any more there. So that's our completely expanded version of this. Now, the reason you're learning how to do this is because sometimes it's much easier to perform mathematical operations on logarithmic expressions if you expand them out. It's especially true in calculus. All right, so the next example, we're at the bottom of page 6. We want to expand log base 8. Oh, I'm sorry, I did that. This was on the bottom of the page. I apologize for that. So that's what I just did was this down here. Let me do this one. Let me go up one now. We want to expand. So this is a simpler problem. Log base 10, and of course you wouldn't have to write the 10, of 0.75 times 293. So This is a product, the very first one, so we can turn it into the sum of two logs. So I'm not going to write the 10 because we can just write it as a common log of 0.75 plus common log of 293. All right, so I reversed those on the page, but no problem. Okay, I'll erase while you turn over to page 7. I'll keep all the formulas up here because we'll keep referring back to those, but you do have to memorize them before the test. Okay, we want to expand and simplify. So I'm not going to write the instructions anymore. They're on your notes. Log base 3 of 3a over b. So we have, on this one, we have a product on top and just a single variable on bottom. So first of all, we have it as a quotient. So take care of the quotient expansion first. So that's log base 3 of 3a. And a quotient is this second one. So you're going to subtract minus log base 3 of b. And I want you to show every step. Now we have a product here. So this is log base 3 of 3 plus log base 3 of a. So that's this part right here. Excuse me there. This part right here. We can expand into this. And then we can't really do anything with log base 3 of b. It's pretty much done. Now log base 3 of 3, log base b of b is 1. So 3 to what power gives you 3? That's just a 1. So 1 plus log base 3 of a minus log base 3 of b. And that is as far as we can take it. Okay, next one on the page. We've got log base 6 of 6 times the square root of 5 over the square root of 6. Okay, first of all, this is a quotient right here. So let's do a subtraction first. That's going to be log base 6 of 6 times the square root of 5 minus log base 6 of the square root of 6. Now the square root of 5, we can write that as 5 to the 1/2. The square root of 6, I want to write that as 6 to the 1/2. Okay, so this is a product here. So I can take a product and change it into a sum, right? Our very first one. So I've got log base 6 of 6 plus log base 6, it's always the same base, of 5 to the 1/2. Remember, I'm writing it as a fraction because I can do something with that 1/2. Minus log base 6 of 6 to the 1/2. Okay, log base 6 of 6, well, that's 1. Now this 1/2 I can bring out front. It's a power, so I can turn it into a coefficient. So 1 plus 1/2 log base 6 of 5. And then I can bring this 1/2 out front. Minus 1/2 log base 6 of 6. Well, log base 6 of 6 is 1, right? This part is just 1. So that's going to be 1 plus 1/2 log base 6 of 5 minus 1/2 times 1. Well, 1 minus 1/2 is 1/2. So I would have 1/2 plus 1/2 log base 6 of 5. And that's all we can do. So I just combine the 1 and the minus 1/2 and I get 1/2. All right, had to smush that in a little bit, but hopefully you could follow it. All right, so that one was actually not that hard, but a little bit fancy. Several steps to get it down to the most simplest form. All right, our next example, you might notice I didn't leave much room to work it. We want to expand and simplify log base 3 of a plus 3b. All right, this we don't have a rule for this. When you have a sum inside the parentheses, you can't do anything with that. You can't take this into as a product into a sum because it's attached to an a with a plus sign. So this is one where we cannot simplify further. So be careful. You only have rules for these things up here. That's one we don't have a simplification rule for. Okay, our final example of expand and simplify log base 10 of the 5th root of a squared times b to the 4th over c cubed. Well, the first thing I want you to do is take that 5th root and let's change that to a 1/5 power. And I'm going to stop writing the 10 here because this is a common log. So this is going to be a squared times b to the 4th over c cubed, all to the 1/5 power. So the first thing I'm going to do is utilize this third property of logarithm and bring that exponent out front. So I've got 1/5 times the log of a squared b to the 4th over c cubed. Now this is a quotient. Now, I'm not going to do anything with the 1/5 yet, but I'm going to use this quotient rule, number 2. I'm going to keep using the brackets. This would be log a squared b to the 4th minus log, again it's base 10, of c cubed. I'm going to wait till the very end to distribute that 1/5. Okay, we've got a product here, a squared times b to the 4th. So that's going to be 1/5 times log of a squared plus log of b to the 4th. Now I want you to resist skipping steps in between because I need you to show me the steps so I can give you partial credit if you make a mistake. Minus log of c cubed. Now what I'm going to do is take these exponents, bring them out front for all three. So we're going to use this third property. This is just 1/5 times 2 log a plus 4 log b minus 3 log c. All right, brought that exponent, made it a coefficient. Now finally, I will distribute the 1/5. So I have 1/5 times 2 would be 2/5 log a plus 4/5 log b minus 3/5 log c. And that's the best you can do. You can't do any more. Pretty cool. Your homework is worksheet 4.6a. I'm just going to glance at this real quick and see if there's anything you need to know about that. It looks like pretty much the same stuff. Number 9 and 10 are longer ones like this. The rest of them pretty much similar to our examples. So Give it a try, and I'll talk to you on the next video.